extensive consulting experiences,
Yep.
and also he worked extensively with the air transit agencies like the MTC and the authority. For example, he conceived one of the Bay Area MTC's $33 million climate innovations grant program, and Steve has also the first smartphone instant ride sharing patent. He also has 3 degrees. One is in business, and one in software, and one in transportation from Columbia, RTI, and Berkeley, respectively. So he's a very good role model for our TPP students. So without much ado, let's welcome Steve.
Hello, everyone. Good afternoon. And I should also say I did a little bit of consulting for the Google self-driving car team as well. So robocars and robotaxis. Is this going to be utopia or dystopia? Are there any concerns anybody has? All right, it's going to be utopia. Kind of project and try
I
to.
don't want there to be a point where like people get banned from driving because it's self-driving cars are safer.
Right, safer, and there's advantages to having 100% of the cars all under the same self-driving regimen and nobody truly driving manually anymore. Any other concerns? A little worrisome, right? But other than that, utopia. So I pulled out some stills from some of the movies. In the upper left is Tom Cruise in Minority Report. And it's worth watching that movie just because the self-driving cars are just fabulous. They go so fast and they go up sides of buildings and such. But there's a central control system that can direct your car over to the police station. So a little bit of a Big Brother aspect that model. And then upper right, we have our former governor in Total Recall, the movie. And you can see with a robotaxi type application, you can remove the front seat. And it's got a natural language interface, a little bit of a smart aleck sort of interface called Johnny Cab. And then the movie WALL-E is a little bit dystopian in that things are so automated, people stop walking, and so everybody atrophies and they just drink sugary soda and consume content all day. They don't get any exercise. Kara Kokelman presented at the seminar in November, and if you haven't seen that presentation, it's worth seeing that on the web. She defined what she terms autonomous vehicles, I'll call robocars today, and what she calls shared, and so those are privately owned self-driving vehicles, and what she calls shared autonomous vehicles, I'll call robotaxis. So it's a service that's owned by something else that you would avail yourself of to get around. And one of the interesting things in her talk was she did the simulation of a 10-mile by 10-mile block of Austin, Texas, and they had 1,600 robotaxis serving about 65,000 trips per day. And if you hailed the robo-taxi 5 minutes in advance, then that gave the service level enough time to respond to that hailing and get a vehicle to you. There's going to be more research along that lines, and certainly for Davis grad students, I would encourage everybody to consider pursuing research in this area. It's so topical right now to do research like this. So many interesting things to look at, and I still think it's a grand challenge problem to increase the occupancy inside of vehicles. One thing to focus on. So, Dan Sperling, your fearless leader, was on KQED Forum. I listened to the podcast. The topic was Hyperloop, and I think he tried to dampen some of the enthusiasm for some of these super-duper fancy technologies. And so I want to make this point. So let's say we have this hypothetical 2020 scenario where you've got self-driving on the freeways, and it's a $5,000 add-on to the luxury sedan that you purchase. You get super-duper cruise control that drives yourself, but you've got to merge onto the freeway and get off the freeway on your own. And for 90% of those trips in 2020, you can text and she's reading a magazine and not pay attention. And then 10% of the trips, you get an alert that says you need to take over driving in 5 seconds, then you drive. So it's not completely perfect, but you've gotten a lot of your time back. And let's say you get 5% of cars on the road with that kind of capability. And my question for you is, what's the result of that? One answer was lawsuits. So we made single occupancy vehicle driving more attractive. Is that a good thing from a planning standpoint? Why are heads nodding? No, that's not a good thing. Yeah, so more vehicle miles traveled, more greenhouse gas, because we induce demand. Because we've made it better to drive. Yeah, so at peak hour, we should expect to see more congestion. But the people who've got this great super cruise control are having a great experience because they're reading a magazine. But the other schmoes who don't have this experience more delay. So it's gotten worse for them. So the rich people are benefiting and the poor people are not. Right? So we've got a social justice issue that comes in with this as well. And then people are induced to buy that house in the Central Valley and have a longer commute, so it's sprawl-inducing. So there's all kinds of short-term as this thing rolls out, there's some negative consequences to consider. So that's sort of the Dan Sperling warning about being too enthusiastic about this technology. So here's a vision from, I think it's 1956, of a robocar, the family. They're not paying attention to the steering wheel. They're playing dominoes. And the ride quality is so smooth that the dominoes don't tip over. Right? It's very hard to do with a suspension system. Okay, but the idea is you get some family time back, right? So it's kind of one vision of it. So I'm going to play a couple videos here. And the first is of the General Motors ENV project. And this is an animation of things in the far future that's really compelling. So this solution would have some vehicle-to-vehicle communication, different than we'll show on the Google Robocar. Showing some platooning, efficiency gains there with vehicle-to-vehicle communication. So all the vehicles are instrumented, so everybody gets away out of the way from the emergency vehicle. Don't try this at home. So now we've changed the travel experience to one where everybody's being productive because they're video conferencing with their coworkers or their friends on the way in. So can't wait for that, right? So that was GM's future vision. And then in this video is showing a robotaxi application where you're hailing transportation service with a smartphone.
To make them safe enough to drive on.
Conference presentation.
A concept. So the idea is that transportation should become, a service. It should become ubiquitous. That you can basically sit in your office, decide you want to go somewhere, and go get the really awesome golf cart to rip out and give you a ride where you need to go. So here they are pulling out of our garage. She decides she's got a meeting she's got to get to. They're driving away. These vehicles are obviously much less expensive than our Priuses. They integrate with off-board sensors in the environment to see oncoming traffic and whatnot, so that they can get the same level of sensing we need, but without having to put, however much we put on the Priuses. Here he is waiting for his car. At this point, now we have transportation.
So hail your service with a smartphone or from your browser, and it drives unassisted to you with the steering wheel. And showing, a key part about robotaxis is showing empty vehicle movement, so it can go to where the demand is, drive by itself with nobody in the vehicle. Okay, so just with all that as sort of random background, so I just wanted to provide a feel for the design and planning issues with robocars and robotaxis and encourage everybody to go off and write papers about this stuff. We're going to do one slide on industry status, one slide on regulation, then go into how this stuff works and what is difficult, and make some incorrect predictions, and then talk about markets and impacts. So we're hoping for Mercedes to come out this year with super cruise control that does lane keeping on the freeways. So you have this hands-free, feet-free, great experience where you would be tempted to want to text. But that was delayed, so it's not there yet. And the idea was it would be do this great hands-free, feet-free, self-driving, but you still have to pay attention. So it's your assistant, but of course you would be really tempted to want to have your mind wander. And then Google's ambitions are very audacious, and they really want the robot to be responsible for your safety and want to deliver something compelling, say in 2017. And they're not only driving on freeways, but they're driving on surface streets, and they're putting in more than 500,000 miles already in their test program. So making great progress. And then I think some people think regulations are going to get in the way, but my sense is the states and the federal government are really just fighting to help enable this technology. They're just so enamored with it. And so the other thing is the companies involved are so big that they tend to just hire away the regulators, so they kind of capture the regulatory process. But I still think, the invisible hand of capitalism is going to ensure that these products come out when they're very safe, or else, they're not going to work from a marketing standpoint. But I just don't think, I'm more optimistic that the regulators are not going to get in the way of this technology from what I've seen. Okay, so let's look at the Google self-driving car, how it works. It's more autonomous in that it's not communicating with other vehicles like that GM ENV scenario connected car communication was. So there's a LiDAR on top that's giving a very high-resolution view of the world in 3 dimensions. And then there's radars also on the vehicle that are longer distance but lower resolution. And there's also a video camera by the visor that can read the color of stoplights, which is very important. So if you're going to take a ride in the Google Robocar, you're not going to be in the driver's seat. You're going to be in the back seat. Okay? And in the driver's seat, there's a safety driver that's responsible for your safety, and if anything comes up, they will take the car out of automatic mode and put it into manual mode. So you can imagine as the software is being developed, they're actually building a knowledge base of what creates a dangerous, hazardous situation, and then they're going to go back in the software lab and fix it. Okay? And then there's an engineer riding in the passenger seat or shotgun seat with a laptop that's showing how the world is being perceived and how the cars beside you are being perceived and so forth. and the engineer can add notes, and then you've got this huge mass of data from that run that you just took, and then the engineer can go back to their workstation and single step through it and come up with a fix for any hazard that wasn't handled well. Basically learning and building as you go along. It's a very data-intensive process. Those 3 key tasks. You have to know your location at plus or minus 5 inches. It's called localization. And you don't just drive on any road. It's got to have been pre-rehearsed, pre-driven. You actually have a set of sensor readings in your database already that you're expecting, and you match against that, pattern match against that. And then you're trying to find moving objects that might crash into you and form hypotheses about what directions they're going. And if you see a hazard, then you've got to change your path to avoid that danger. And then there's path planning. So, for example, here, the car is going to go through an intersection, and it's interesting that the Google car has a protocol where it sort of gently eases out into an intersection to a point where it thinks it owns the intersection, then it goes really fast through it. But it's interesting how we navigate, say, a four-way stop intersection as humans, and how that goes. And this last of my 3 videos is showing.
All right. I'm not pressing anything.
This is on top of a parking structure,
Yes.
showing Google self-driving car in a racing type situation, swerving around pylons.
All right.
Can you set it to 11?
There are all sorts of notes.
So this was at a TED conference, and this guy here is actually one of their top engineers. He's not just some schmo driving it. But so the point on the racing is that essentially these self-driving cars can stay on the same line through curves, and so they're probably better than the average human driver by far, and can replicate that behavior robotically. So what's hard about robotic driving? Well, anything that's hard for a human to do is probably hard for a robot to do. So in Palo Alto, where I'm from, here's a 4-lane arterial street on the left. So 2 lanes going 50 miles per hour north, 2 lanes going 50 miles per hour south, and here's a little collector street with a stop sign. And if you want to make that left turn there, the problem is there's street trees in your line of sight. So if you have a computer vision sensor system and there's a bunch of trees in your way, it's hard to figure out all the obstacles that are going 50 miles per hour because they get hidden on a regular basis by the trees. So a question is, so what do you do about it? Product developer. Any thoughts? Yeah, so you could add some more sensors, and so potentially put a box somewhere that's a bit of infrastructure that's got a better line of sight, and then you can have communication from the infrastructure to the vehicle. Could be one solution for that. So we cut down the trees. Yeah, you could get really good at your computer vision, right? You could just route around this, so never drive here because it's too hard. Or if you were powerful enough, you could put in a stoplight. So, but you've got to do something tricky. There are use cases that are pretty tricky for a robot to handle, and this is one of them. Yeah, I mean, you would probably reroute earlier than when you got to the stop sign. You would figure out, oh, I don't want to do this. And then you would reroute earlier and take another street. Yeah, very much so. Or if you had a driver in it, you could switch into manual mode and you could do it. Yeah, and sometimes it's a little nerve-wracking getting onto it, and other times, there's no cars there, so it's no big deal. But here in Palo Alto around rush hour, it's pretty tricky. Even for a human, most definitely. So what are other things that are difficult for humans to do? Well, driving in snow, and that's really hard for computer vision systems to see through. And then these pedestrians, they're really getting in the way. And bikes are more dangerous because they're faster and they take more random, sudden movements. Sometimes things that are supposed to be static aren't, like roads. There's erratic driving. I really like this picture here. It says, honk if you love Jesus, but text while driving if you want to meet him. And then if you're driving on the hills of San Francisco, a lot of times you don't have that line of sight that you'd like to have because it's so steep. So that's a problem for a computer vision system. And surface streets are a lot harder than driving on the freeway because there's a lot more hazards. More things that are difficult with human driving. Sofas that are going to fall off. Static debris in the road that could puncture your tire. Construction. These narrow freeway merges, they're really hard to deal with for humans. And then, besides having the human difficulties, if you're a robot, then there's some maneuvers that currently we depend on eye contact with other drivers for, and you don't have eye contact, so what do you do? So how do you deal with traffic cops? Any thoughts? The solution is to automate the police. I love it. So if you were a robocar, you could switch from automatic to manual mode. If you were a robotaxi system, you could have a control room that's activated, and so there's some control personnel that's got a video camera out that can read what the traffic cop is doing. If your computer vision system was really sophisticated, it could read the police officer, the traffic cop's hand signals, so forth. And the police officer could have a smartphone app that could somehow communicate. And then when you think about doing one of these tight merges onto a freeway where you're used to having maybe eye contact, you look over to see if the other driver is actually looking for you. Right? If sometimes you see no, then you slam on the brakes because that person's not going to avoid a collision. The question is, what kind of a user experience would you design to deal with that situation? How could the robocar communicate to the other human driver? So I think that's a really fertile ground for those kind of designs. And then there's a question of, will teenage boys take advantage when they know the algorithms of the self-driving cars? Make the self-driving cars do all sorts of things to avoid accidents. And there's things that generate false positives. So you might think a Mylar balloon, robotic vision system it's a huge obstacle that's going to cause a crash when you could just sort of drive over it. And Steve Schladover from UC Path also has some cautions. He says, okay, sure, I get the point that you can eliminate drunk driving and other human errors, but now you've got this really complicated system of hardware and software that can have cascading dependencies and new vulnerabilities. So you don't just get a freebie where you get to eliminate the other things. And Steve Schladover has some good credibility because there on the bottom right, he was involved in one of these early platooning projects. And then he also points out that the fatality rate is so low right now, it's really hard to make a case that your self-driving system is super safe without driving millions of miles, which you really don't want to do because it's pretty expensive to do that. And then he also points out that the Google's LiDAR-based system is going to have a slower reaction time than a vehicle-to-vehicle communication system that's got wireless communication between vehicles. So he's worried about that. And then he's saying, well, once the robots are doing all the driving for us, we're kind of like WALL-E, where our driving skills atrophy. But every once in a while, the robot's going to want to throw you control. But if your skills have atrophied, and you may be needing control the car in a situation where it's really kind of dangerous and you need some skill, and you haven't done anything. You haven't driven in 3 years, you know. So here are my incorrect predictions, and everybody's predictions are going to be wrong. So in 2020, 5% of freeway are going to have this great super cruise control with lane keeping. It's going to improve the benefit of single occupancy vehicle driving, so it's going to have some bad policy implications that maybe we should attempt to think about and mitigate before we actually implement this stuff. And then I boldly predict there'll be 2 robotaxi small circulation systems that'll provide great examples of car sharing benefit, which is reduced VMT and so forth. And so maybe there's a public policy need to help promote these kinds of robotaxi systems if they can provide public benefits. And then let's say in 2045 we're going to have lighter weight cars that get 200 miles per gallon, and we're going to replace the fleet of cars twice up to then, and it's going to be great, but it's going to be pretty late in terms of the climate thing to actually help cut a lot of greenhouse gases time when we need to. Let's talk about some of the different markets for robocars. So which commuter should we target? What are the characteristics of commuters for these things that you sell these cars to? Rich people, people who drive a lot, but people who have a lot of highway miles, right? Because this is for the for-sale robocar market that's freeway focused, and it's better. It provides more benefit to somebody with 40 miles on the freeway than somebody with 5 miles on the freeway. And what do people want in their robocar? Well, they want an office-like environment where they can be super productive, so it's not like driving. They do not want to get motion sick from reading content. Probably want a natural language interface. People would love to sleep, although that's probably not going to be allowed. But I mean, I think what people really want to do is they don't want to drive; they want to sleep on their way to work. And people characterize a good commute by saying time went fast. You want to show up at work relaxed, with more energy, ready to kick some butt. And talked about the 5-second rule. And what about people who've got vacation homes? Holiday travel. Are they a good market? People are going to Tahoe from here. Probably people who go 10 times a year rather than once a year, right? What's that?
They also typically have money.
Right. So again, rich people, right? And what do people want in a trip to Tahoe? Well, people I talk to, they want to get drunk on the way. They want to party. But that's probably not going to be legal. But again, or they want to sleep. And again, that's probably not going to be legal. And families talk about having more family time and a more family-friendly interior. So what are the impacts of this? So we'll reduce fatalities. Eventually, you can reduce the car weight and increase your miles per gallon. And given critical mass of cars or dedicated lanes for robocars, we could have smoother driving on the freeways, could get higher fuel economy that way, and less of traffic ripples and congestion and accidents, closer following. And we could provide mobility for sight-impaired folks and seniors, kids, although people probably don't want 6-year-olds going in the robocar by themselves, but people seem to be okay, sort of like 12, 13. And people want valet parking, but that's going to produce more driving, especially if your parking lot is 5 miles away. So again, we'll probably get short-term impact of more VMT. Then there's the question of social equity. Do you end up with a stratified society where you've got the superstar programmer who lives in Tahoe and commutes to the Bay Area at 100 miles per hour, codes the whole way? driving while poor becomes less safe, potentially, and less pleasant. And would you pay $5,000 when you buy your Mercedes sedan for this assistant as an add-on that gives you the great freeway experience where you can read your magazine? Or would you want to spend $10,000 extra for a full robocar that can drive on surface streets? Or what's your willingness to pay? I think it's a good area for research on this. And then is that going to make a business model work as well for this technology? Sensors are currently expensive, but it looks like they're going to get driven down. You don't want to spend $100,000 for this feature, right? And for robotaxis, there's going after the taxi market. And so Uber, Sidecar, and Lyft are smartphone-based taxi-like services. Drivers make money working on a shift. And typically these services are targeted at dysfunctional urban taxi markets like San Francisco and Seattle. You get friendly, fast, reliable service. And there's this amazing surge pricing where it's really expensive at 1 a.m. if you crawl out of the bars in San Francisco because everybody needs a designated driver at that time. And Sidecar CEO Sunil Paul says, I can't wait for robotaxis to get rid of those. And then if you think of like the New York City taxi market where there's tons of taxi drivers, there's some political power to fight this. But in New York City, it's interesting that the typical taxis are delivering 3 paid trips per hour. Average length is about 2.8 miles. Average occupancy is 1.4 passengers. And about 40% of their miles are running empty. So you could have labor cost savings from getting rid of those taxi drivers, and you could more efficiently dispatch your fleet of vehicles around New York City and have fewer empty miles. You could serve up some local content to people based on knowing who they are and where they are. Also this notion of Zipcar that drives to you, but that's going to converge on being a robotaxi. With self-driving car technology end up being the same thing over time. And what about if you owned the car, drove it to work, and then it would go off and earn money for you, driving other people around during the day? Peer-to-peer model. And the current car-sharing market, the vendors have to acquire parking spaces to park cars, and you can park in less expensive spaces if you've got automation. You can utilize your fleet better. You can handle a car arriving late because you can bring in another car from somewhere else to provide the next trip. And you can provide more car variety because the pickup truck can drive up to you in San Francisco at once a month. What are the impacts of the robotaxi market? So think from Sis Jahin's research, one car share car takes off about 10 cars, and BMT goes down by 45% per capita, so it's kind of a lifestyle choice. Transit use goes up. And with this kind of reduction in private cars, and you make fewer new cars, and each new car takes about 8 tons of CO2 in manufacturing. But of course, you reduce the annual revenues of the automakers, and they might not like that. And you could, with fewer cars, you'd free up all these parking spaces. So there'd be all this asphalt. You could do some new real estate development, real estate play. And you can order up the smallest car for your job, so you don't have to buy that SUV. You basically order up a Prius most of the time. And wouldn't it be great if we could provide better mobility for low-income and transit-dependent people? But the question is, who's going to subsidize this? There's a lot of potential there to make people's lives better, but probably need to come up with some money to make that happen. Let's talk about robotaxi services in suburban areas where you typically don't have driving taxi services. But we also have this notion of wanting to convert a 2-car family to become 1 car plus robotaxi plus, say, a Zipcar that you get for longer trips, plus a transit pass, plus you bike more and you walk more, and you borrow a car from your neighbors, right? But it's bad to launch a service that's sparse where, say, if you launch it for the Bay Area with 7 million residents, you wouldn't want to have just 100 robotaxis because they'd end up with these orphan trips where somebody goes from San Jose to Berkeley and then there's no trip to take it back, right? So you end up deadheading your vehicles a lot. So in Kara Kokelman's model, she had the 10-mile by 10-mile area in Austin, and the question is, can you actually get smaller bounded areas and still have critical mass? So I look at places like Redwood City in Palo Alto. It's got a Caltrain commuter rail station, a nice walkable downtown with a traditional street grid. It's got a bunch of tech jobs pretty close by. And can you pick people who would use this service who would both live and work within a bounded area? So you could satisfy 95% of their trips, and then they take a zip car if they're going to go somewhere else. And then can you also target within that area non-workers and students? Again, you're looking for people with a trip universe that fits within your bounded area for members, right? Because they're going to benefit the most. And also, people can work outside of the bounded area as long as they're going to take transit. So you can get them on the first mile, last mile to the train station. So and hopefully you can get that car sharing benefit even in suburbia. But all these places where you have traffic congestion, just when you need the most capacity at peak hour on the arterial streets, your capacity drops because congestion goes up. So that's something you have to watch out for in your modeling to make sure your system doesn't break during peak hour. And anything we can do to raise the cost of driving, like increase the gas price, is going to help all these mobility services, help create demand for alternatives. But $3.65 per gallon gas doesn't really help things. And let's think a little bit about the user experience for robotaxis. So let's say you've got to do a rendezvous between a robotaxi and people on a busy street where you've got parallel parking with a bike lane, and there's driveways from apartments, and there's fire hydrants. So this is something that taxi drivers are really good at, right? It's a great AI problem that's really hard for a robotaxi. And you can't quite, if you're a robotaxi, you can't quite see, half a block down the street to see what spaces are in front of you. So it's tricky to double park as a robotaxi. And then what about if it's a foggy, rainy night where the visibility is reduced and you've got to do a rendezvous and you've got 3 people waiting for 3 different robotaxis that are coming up? So how do you do that sort of situation? So sort of interesting use cases, I think. And then if you're going to go without a car, you don't have a trunk to store your gear anymore. So how are you going to schlep your gear around, your sports gear, hobby, or what have you? Get a little hook-and-go cart like she's got in the bottom right. And then from a user experience standpoint, the Google Now concept is that Google is sniffing your calendar and figuring out when your meetings are, and they're faster than real time. So 10 minutes before you think about it, they've already ordered a vehicle, a robotaxi vehicle for you. So it all just like, you're like, okay, great, I've got this valet that's doing everything for me. Smarter than me and is more present-minded. So you end up in these applications like prodding somebody to get up from, it's time to pack your backpack now, get up out of your desk, go out on the street because the robocar is going to be there in 37 seconds. Something that's managing the selection of the start and end address and the payment and so forth. So I think it's pretty interesting. And on the robotaxi economics, what do you want to charge for this thing? So here's a look at San Francisco taxi rates. So that's one metric. But if you charge taxi rates, you can't charge as much as if you charge lower if you're competing against the cost of auto operation. And then kind of in the middle is city car share, which say it's got an hourly rate for a car share of, say, maybe $8 an hour. So the audacious thing to do would be to compete with private autos, so with an all-in cost of 55 cents per mile. And the question is, would you be willing to pay 75 cents per mile for a robo-taxi service, assuming you were going to drive about 45% less? So you'd still come out ahead. How would you design the pricing? Because consumers typically don't think it. They think about their gas cost and not think about the maintenance cost, the insurance cost, and all the other things that are perceived as sunk cost. So that's it. So a quick run through on this stuff. Questions? Exactly. Are you worried about the dystopia? The Wall-E dystopia? Yeah, or stand up and project into the microphone. So the question is on the social equity issue, how much discussion has there been on it? And my answer would be there's not enough. It's a really fertile field, and at policy level, I think it needs to be top of mind rather than something that's lagging behind. Question way back there? But that's wrong. I said I was wrong.
Sure.
Okay.
Yeah, you can caveat it well, but I mean, just looking at emerging technologies like vehicles or whatever, we talk about things a lot, and electric vehicles, they're increasing in share, but they're still pretty small, and that 5% even seems ambitious. So, how did you arrive at that number? And have you seen other estimates of that?
Yeah, I would say that there's the question was, how well vetted is my 2020 5% market penetration for robocars forecasts? And I would say not very well vetted, and there's a bunch of other not very well vetted forecasts out there, including, I think some really optimistic projections from some of the market analysts, but they sort of have an interest in over forecasting so they can get more money for consulting to automakers and so forth. Right? They're sort of, in a lot of these forecasts, there's no business in having a pessimistic forecast. But you're right, and I think there's sort of been kind of a pretty flip idea that you were going to turn over these fleets really rapidly and get to this vision of super lightweight cars where you don't need airbags or anything. All the safety stuff, that's all extra. So we're going to cut the cost of cars and lower the weight. It's non-trivial to turn over the fleet.
If you don't have a good regulation, what kind of city coexist with this car? So what are the impacts in the land use, in the site where people live?
The question was, what are the land use implications for this technology? I think that there can be some sprawl-inducing land use implications that we really want to mitigate policy and want to call out those issues up front and try to think through them. The first implementation minimizes that. And I mean, there is a chance that this technology will come so fast that it'll be faster than planners and government will be ready for. And then, you just kind of have this free-for-all. So I think there's a real need to get ahead of this on the planning profession and government.
Yeah, so I'm still concerned about the economics of this thing, particularly at the lower income level, where if you don't have a car, you don't have mobility,
Yeah, exactly. So,
Bicycles are almost nothing.
yeah, exactly. Exactly. So the question was, again to this social equity point, and selling technology, and how do we make it available to low-income folks at a good price, and who's going to pay for it if those folks can't afford it? Boy, it would seem like for transit-dependent folks who have to take 3 different buses and do transfers to get to jobs, wouldn't this be great? This is a perfect thing for them in terms of making their life better and getting them back 2 hours a day to do something else with their time. So again, I think planners and advocates to get on top of this issue sooner rather than later, so the technology doesn't outrun the planning cycle.
Change to the actual physical infrastructure, right? Like totally recall certain vision. Has there been any research done on public opinion to see if the public would support financing that? Because you pull for the gas tax, miles tax, people oppose it. Has there been any research that the fact that this may have some like sex appeal can help get it financed, or is it all just going to be private?
I think the preference is from the automakers, is to privately develop it. But if you need infrastructure to vehicle solutions, then somebody's got to pay for that. And I think there is an opportunity for robotaxi systems to have cities actually procure them, customers for them. But I think the preference would be to just be able to implement them privately without much regulation. But a city would work more efficiently with a monopoly with one vendor for that, rather than having 3 vendors competing, much like you want to be able to do the dispatch efficiently. Yeah, there's definitely been like German electric tow bar research to platoon trucks, most definitely. So that level of automation, there's interest in that. There's a startup in the Bay Area that's trying to do 2-car platoons, and the first truck actually, for some reason, actually becomes more fuel efficient when it's got a truck behind it. So part of their challenge is to match truck rides so that you can actually get 2 trucks that are going in the same direction. So it's great to be able to do the platoon, but then you've got to find where there's an actual business need to have 2 trucks that are going in the same place. Their business model is, I think, really compelling to the truck driver. It's kind of thing where So this question is about robotaxi systems introduced as kind of a local transit system. And so I think the places where it makes the most sense, where you're feeding mass transit, it's going to work for more people, where they've got a way to get on Caltrain or BART to get to different job sites. So as a circulator, last mile, first mile, so you're getting the trip to the grocery store, you're getting the trip to the gym, to the Starbucks, to various recreational opportunities. And then you're also having people having their mobility universe where they can get to San Francisco or San Jose or some other way. So you're being complementary to that and increasing ridership on line haul transit. some question when you, so that's a small bounded system. The question is when you grow everything up, how that all works. So you grow Bay Area wide with 100,000 vehicles. What's the impact on model that? Right, and for a robotaxi system, taking a 40-minute trip for one person going someplace is somewhat low utilization of that robotaxi during peak hour. You actually like to be giving trips to 10 different people during peak hour. So it's somewhat expensive to take those long trips. So they're not necessarily that desirable. Right, question is about first last mile by taxi to a train station. And that is not happening a lot right now. And so I was envisioning something that was less expensive than that, and kind of seamless, so you could actually be timed to your BART train so that you got this nudge on your smartphone to get off your duff, put your backpack together, get out the door, and the robotaxi system is going to guarantee you get there with exact amount of slack you need to go down the stairs and pay at the fare to get in. So it's pretty seamless experience for you. It's got to be low cost, and it is, you're right, it's a new behavior. And really trying to get it to be so seamless that, we typically think of, like, much of America, the transit village, the walkability radius is like a quarter mile only. It's really disappointing. And extend that out to 2 miles so that your train station gets a lot more productive.
The last one. So there's like the federal initiative with the connected vehicles. On the other end is the Google. These two forces are converging to make it work together. For example, you don't need to have a completely
Right. So the question is, with the Google approach and the connected car approach, is there any kind of moving together on those initiatives? And from what I've heard and read about from Google, they are going on their own path, and they're not looking to that. And they feel that by being very self-contained, then they don't have to depend on a critical mass of connected cars to communicate with. They're concerned about there being legacy cars that are what deaf and dumb, are not communicative. And so they still have to deal with those, so it's no great advantage to them having some cars talking to them.
Okay, with that, we'll cost of this car. Every 2 years they'll up the price.
And I think the LiDAR is really expensive. You produce right now. I don't think the cost of goods is
Spontaneity, like getting nudged to like leave the door.
Give it to anyone else.
Still just.
Okay. Yeah, I can give my own.
Financially, some level of.
You can put it on that and I'll go. My computer's next to me.
Hundreds. And so now, like, so now we can put all the new shiny stuff over here outside.
Okay.
Going into it.
There's a copy on our Yeah, so,
Oh, this is IPS.
so IPS will have a copy of it.
Okay. Yeah, maybe I'll send it to myself. That's okay. Okay.
Tell me.
Then you switch up to another meeting at 4 o'clock.
Being my host.
Basketball shoots up,
Yeah, this,
twist off.
Good luck in making cars.
exciting
Good
stuff.
luck on your projects.
Thanks.
Getting some hardware.
Yeah, well, I think we'll definitely
You'll be caught in the past, Natalie.
just get a maybe donate a vehicle. The other thing are very cheap.
Right.
Cars. Oh, so the North-
A lot of entrenched interest.
Cars.
Job when you got a car.
Yeah, here is new. Yeah. Okay, have a nice weekend.
Farming, you know, in Iowa or whatever. One guy reap as much wheat as 100 guys used to do 80 years ago. Basket Bible Belt.
I mean, there's no doubt that
That's what I think.
Don't go for latte.
People who have jobs are still working 40 hours. It would have to be, you know.
Like a version of the American Dream. They go somewhere.
Because I've got the computer program. 10 projects.
I don't. There's enough people protesting Google right now. Approaching them with a